This is an automated truck, and it uses the technology that we designed at Daimler. It's called RTI, Remote Truck Interface. So what we have here is a truck that uses a differential GPS to navigate very accurately on a surface. As you can see on this parking lot, you can see I'm started drawing the lines. You see, this is actually all the demonstration I did this morning. The system is accurate, like a few centimeters accurate. So what we have prepared today for this demo is a simple circle route, which I have taught the truck this morning. So I physically drove it. The truck has recorded and it's going to replicate it. What is actually, you will see, it might happen because of the wind conditions and so on, and the gravel surface. Sometimes it gets bumpy, and for safety reasons it stops. It detects the cabin moving too much. It doesn't do it all the time. Around that area it does it. We'll see if it does it later. Of course, in this demo now we don't have obstacles. I made sure that all these concrete blocks are not detected. But the laser scanner here, you can see here is a laser scanner signal. You might see it on the front of the truck later. If it would detect an obstacle, it would immediately stop. And then this is a prototype, right? So what we have implemented is we always ask a safety driver to manually clear any obstacle that is seen. Even though the obstacle is disappeared, we have to physically say it stops. Also, sometimes let's see what happens later. What I'm doing right now is the truck is stopped at the end of the circle. So I will manually drive a meter or two in order to take the truck to the beginning of the circle, and then I will start the automation. So now the truck, in this prototype we have a little switch, manual and the RTI, remote truck interface. I switch it to manual. I release the brakes, and I just drive a few meters. In this display that we have inside the cockpit, we use it, it's not necessary at the end of the product, it's just for this demonstration to help the driver detecting the beginning of the segment. Here what I'm looking is a little zero at the beginning of this in this field, and this arrow helps me steering it. So I just drive a few meters ahead. Here we go. So we are at the beginning of the segment. Now I just released the brakes. Now the brakes are going to be electronically steered by the truck. I enable the RTI, remote truck interface, and I just say go. I push the button, and then now the system will take control. You see the steering, electronic steering is taking control. I hope that my colleague is not being detected by laser scanner there. That's fine. Now we are driving on the path that I taught the truck today. As you can see, the steering wheel is correcting continuously the trajectory because it has a precise trajectory to follow, but because of the pavement and the gravel that moves, it might change a little bit. Now where the truck used to stop this morning, yeah, see, this happened. It happened because of the flat surface, but then we start again. We detect a little correction and we go straight. See here now we do another curve and we go back to the starting point. This is of course just a demonstration today. The idea is that we want to use such a technology inside gated areas, and we just have to train the truck manually or via computer, and we teach all the possible trajectories within the private area of our customers. Then what to do with it? Well, this is exactly what we are trying to understand with our project, Automated Yard Solution. And we want to learn from our customers, basically.
So what will you think will be the most suitable way of using this technology? In what different areas?
What I've seen is internal logistics, for example, fulfillment centers, when large compounds where there are multiple warehouses that were built at several periods in time, for example. We see that many customers need to consolidate the load of a certain truck from a warehouse to another one. So there is always the same shuttle routes that need to be done. And this is an ideal solution. The truck can go, get backward in front of the docking station, and do the same thing on the other side, continuously, periodically. It depends on the use case. We want to give flexibility, but internal warehouses for fulfillment centers, it seems to me the direct application of it.
And what's the biggest challenge in the development of such a system like this? Is it the software or gathering the sensor data, or?
I think none of them. Software, it's not a real problem. I would say the mixed traffic within some of the scenarios that we have seen. Some yards are very complex. They have human walking. They have bicycles. They have opened the streets to different type of traffics, and we need to make sure that the system stays always safe. And such a technology will always play a defensive role. So whenever sensors detect an obstacle, they will immediately stop. So maybe we might need dedicated routes for automated trucks, or our idea is to have a full integration of a truck within the warehouse, within the gated area. So controlling traffic lights, gates, giving priorities to the automated truck. We believe that through full integration we can cope with mixed traffic and complex scenarios. So this is the major challenge, I would say.